Lesson 27 has two parts. The first part is about the distributive property, and then the second part is on simplifying decimal equations. Now, you learned about the distributive property back in lesson 17, and if you remember what that is, if you had an expression like this, you could do addition first in that and say 3 times 3. After you do your addition, you have 3 on the inside there. 3 times 3 is equal to 9. Or you could do multiplication first, which is what the distributive property is about. You take the 3 on the outside, multiply it by the 2, and you have 6. And then you do 3 times 1. Always put a plus sign in between them, and you'd get 3, and that equals 9. So either way, you get the same answer. And then you've also done some, or maybe you had some variables in there too. 3x times a plus b, and you did the distributive property on those as well. 3x times a would be 3xa, and then 3x times b is 3xb. Now, what you're going to learn next is, you guessed it, some more complicated expressions to expand using the distributive property. In these ones, they'll have powers that you'll have to deal with, and you'll be using your product rule for exponents to simplify some of the terms. Let's go ahead and do some practice problems. Look at practice problem A. Let's go ahead and expand that. And so anytime you hear that word expand, you think, oh, I've got to use the distributive property. I need to distribute that factor or term on the outside of the parentheses over the 2 on the inside. And so I do multiplication first. And so I would say a squared b, and I multiply that by the b squared on the inside. Then I put a plus sign down, and then do a squared b times that ay on the inside. Okay? Then I go ahead and simplify each expression. And so the first one there, I have a squared b times b squared. And so the b times b squared, I can use my product rule for exponents, and b to the 1 times b squared is b to the 3rd. And so that'll simplify to a squared b cubed. And then the next one, I've got an a squared and an a, so I can simplify that to a cubed times b times y. And so there's the answer there. Now again, just to refresh your memory, remember the order that those factors are in does not matter. Like in the first term, it could have been b cubed a squared, and the second term could have been b a cubed y or something else. That doesn't matter. As long as I have the right, you have the right factors in each term and the right powers for each one, and you've simplified them correctly, then that's what matters. Look at practice problem B. Now on this one, you've got a term that's on the right side of the terms inside the parentheses. You can still use the distributive property though. Just take that cx squared and we can multiply it by ax. It doesn't matter which term on the inside we do first. I'll go ahead and do the ax first. Cx squared times ax, and then plus cx squared times a negative x squared. We consider the term and the sign in front of it. Cx squared times a negative x squared. Okay, so now let's look for places to simplify here. And we'll have cx squared times ax. We've got an x squared and an x. We could simplify that. And so let's say acx cubed. I like to put them in alphabetical order. And then the next one, let's move that negative sign out to the front. And then we have cx to the 4th. And so that is our expanded form of that expression, acx cubed minus cx to the 4th. Let's do one more problem where we expand to simplify it. Look at this one. We have 5x squared y cubed on the outside, so we'll multiply the two terms on the inside by that. And so we have 5x squared y cubed times xy to the 4th, and then plus 5x squared y cubed times that negative 2y squared. We always consider the sign in front of the term when it's inside the parentheses. So now let's go ahead and simplify each term that we have now. On the one on the left, we have an x squared and an x. That would make 5x to the third. And then we have a y cubed and a y to the fourth, so that would give us y to the seventh. And then the term to the right, we have a 5 times a negative 2. Let's go ahead and multiply those coefficients together. That would give us a negative 10. And then we have x squared, and then y cubed times y squared is y to the fifth power. Now, have to keep in mind always when you're doing these problems, the order of the factors does not matter. That's why in that second term, when I simplified it, I could do 5 times negative 2. I didn't have to move them all around because I know that the order doesn't matter. And so I can just do that part in my head. 5 times negative 2 is negative 10. And then I do the x squared, and then I added the exponents on the y terms to get y to the fifth. Let's go ahead and look at part B of this lesson, and that's about simplifying decimal equations. Now, we've already done some problems where we simplified decimal equations. What we're going to do different here is we're going to convert all the decimals into whole numbers. And the reason we want to do that is because it's just easier to work with whole numbers, usually it is anyway, than to work with decimal numbers. Look at practice problem D. 0.4x plus 1.4 is equal to 0.7. So what we want to do here is get rid of the decimals. And so what we'll have to do is multiply by a multiple of 10 that would make all those decimals whole numbers. And what we want to do is look for the smallest decimal, and that would be the 0.04. And we'd have to multiply that by 100 to get it to be just a whole number of 4. And so basically what we have to do on these problems in order to make them all whole numbers instead of decimals is we need to multiply every term, use our multiplication rule to multiply every term by the same number, and then we won't change the equation, we'll just change the way it looks. So let's just go ahead and I'll just write a 100 next to each of these. So we've got to multiply everything by 100. And that means moving the decimal place to the right too. So we'd end up with 4x plus 140 is equal to 70. Now everything's in terms of whole numbers. And so let's go ahead and simplify and solve for x. So we would use our addition rule to add a negative 140 to both sides. Cancels on the left, and so we end up with 4x is equal to minus 70. Now we need to divide both sides by 4, and the 4's on the left cancel, and we end up with x is equal to negative 17.5. So we had that one extra step there at the beginning of converting everything to whole numbers. And I mean, you don't have to do it that way. If you're really good with working with decimals and you're confident about doing it that way, then you can just solve these problems like that. If you're more comfortable working with whole numbers, then go ahead and multiply each expression, each term, by a power of 10 that gets rid of, or a factor of 10 that gets rid of all of your decimal places. Look at practice problem E. We have 0.3x plus 0.5x equals 4.8. Well, you should notice there that we have like terms on the left, so we want to add those first. And so we would end up with 0.8x is equal to 4.8. Now let's go ahead and multiply both sides by 10, and that would get rid of our decimals, and we'd have 8x is equal to 48. So now all we have to do is divide both sides by 8, and x equals 6. So in that problem we needed to add the like terms on the left first, and that got us down to just one term with a variable in it. And then we just used our division rule to solve for x. And of course, multiplying both sides by 10, that helped us convert the decimals into whole numbers, and that just made it easier to work with and to figure out what the answer was. Now sometimes what you can do on problems like that is just think about the multiple of 10 that you need to multiply. Think about how that would change it. Do that part in your head. Like you could think, well, 0.8x is equal to 4.8 in the same way that 8x equals 48, and so I could figure out real quick what x was that way as well. So you know how you do with decimals. If you make a lot of mistakes when you're working with decimal numbers, then it's probably a good idea for you to try to get rid of those decimal numbers by multiplying by the appropriate multiple of 10. And you multiply every term by that same multiple of 10, and that gets rid of the decimals, and then you can go ahead and solve it. Okay, well that's all for lesson 27.